I was a kid, because he needed to do the processing manually and then take them back and put them back into the supercomputer. Now you can just spin one up. It's cool. How old am I? I know. Next up, this is a fellow who's become a friend of mine, Ken Goldberg, a Berkeley professor, a researcher in robotics, published over 150 papers in the theory of robot motion planning. He's the editor-in-chief of the IEEE Transactions on Automation Science and Engineering. How many of you remember the first ever robot on the internet called the Telegarden? You remember that? It was like Farmville before there was Farmville. It was a real farm. A living garden tended by tens of thousands of people. With his students, he studies computer-human interfaces, CHI, and collaborative filtering. And he has been appointed the Craigslist Distinguished Chair in New Media at Berkeley as well. He's going to describe a little bit about his latest research, but also with the theme of announcements, he's going to make an announcement about his new startup. So, Ken, welcome to Web 2.
Looking for a testament to youth and
Okay, thanks, John. So we've been talking about the future, but I want to right now go back 200 years to a time when Napoleon faced a big problem. He was sending his men out on these missions, longer and longer journeys, and there was no way to preserve their food. The food would spoil after a couple of days. So they were going hungry, morale was low, and Napoleon asked all of his best scientists to see if they could figure out a solution to this problem. But I better have this clicker. But none of the scientists could figure out a solution. Now, Napoleon was not a big man, but he knew how to think big. So what he did was he announced a national contest, and he offered a grand prize for anyone who could come up with a solution to his problem. So ideas started to pour in from all over. And eventually, a man who had been working alone in his basement stepped forward with a solution. He had discovered the vacuum process to create what we now know as canned foods. The French soldiers got their escargot, and the rest is history. Since Napoleon, leaders have learned that the best way to solve really complicated problems is to cast a wide net, to generate a large variety of diverse ideas. In 1953, a man named Alex Osborn came up with a systematic process for generating lots of ideas. He wrote a book, and he coined a new term, brainstorm. We've all used it. Get people in a room and come up with a bunch of ideas. But what's amazing is that the process that Osborn came up with hasn't really changed in 60 years. Yet almost everything else has. There's a proliferation, as we've heard in the last few days, of devices and sensors and networks that's catapulting us into a new era where the scale of data cannot be managed by traditional relational databases. To me, this data frame that we've been talking about echoes the concept of enframing that Heidegger proposed as the essence of technology in 1953, the same year as Osborn's book came out. For Heidegger, frames create boundaries that separate us from nature and from each other. But at this conference, we've been hearing about how the social enterprise is breaking down these barriers between sales and marketing, between production and research, even between the employees in an enterprise and the customers, or the public at large. Social media is allowing data to be shared so easily that traditional frames don't apply. And the crucial question is, how can social media and its data be used as tools to solve important problems? In other words, can big data generate big brainstorms? Now there's a dilemma. Generally, when you increase the scale, you increase more and more people participate, you sacrifice speed. It takes longer and longer to sift through and find the valuable ideas. Several smart people and companies have been thinking about this problem. But the existing methods collect ideas into lists, and lists are linear. As they grow in length, they get harder and harder to evaluate. And another problem is the discrete ratings values. It's either totally awesome or this is completely worthless. These are blunt instruments. There's no subtlety. So they don't support the higher order statistical analysis that can be used to filter out noise. Social media gives us much bigger haystacks, so it's much harder to find those needles, to extract the signals from the noise. How can we achieve both scale and speed? It turns out that we can get insight from an unlikely source: robots. Robots work in nonlinear spatial environments, and they must rapidly filter very complex, dynamic, noisy data. As John mentioned, I've been studying robotics for the past 20 years, and I direct a research lab at UC Berkeley. Over the past decade, my students and I have been applying ideas from robotics to problems in social media, in particular the speed and scale dilemma for social innovation. We developed a series of interfaces, and we made them available online. Here's where the data frame comes in. We collected over 6 million data points from over 150,000 people. We share anonymous versions of this data with other researchers who have published over 500 papers applying and extending our results. We, my own students and I, have used the data to develop and test algorithms, such as this one for collaborative filtering. It's based on dimensionality reduction and efficient data structures that was granted a US patent. So models from robotics, combined with data, can give us new analytic algorithms that can be scaled to large numbers without sacrificing speed. When Barack Obama was elected president, the Secretary Clinton and her staff at the State Department asked us to develop a system that would invite people around the world to suggest ideas on topics related to foreign policy. A version of our system called Opinion Space is still active on their website. Since then, we've worked with a number of other labs at UC Berkeley and with the Fortune 500 corporations in consumer products, healthcare, and manufacturing. The result is a new process and a new company that we're launching today. We call it the collaborative discovery process, and the company is Hybrid Wisdom Labs. So what I'll do now is give you a very quick tour of what we call the collaborative discovery engine. Each engine is focused on a particular topic and a key question, such as this one suggested by the US Department of State. Each colorful circle, which we call a bloom, like a flower, represents an idea suggested by a participant. The position of each bloom is based on the opinions of its author. The map conveys the scale and diversity of the responses. The size of each bloom is related to how valuable it's been judged by other participants. The judging occurs when participants click on blooms and evaluate it using two continuous scales, 2 dimensions. First, how much you agree with the idea, and second, how insightful you feel the idea is. The data showed us that these 2 scales are not strongly correlated. Our algorithms compute a value, a dynamic size for each bloom based on all of this data. The result is a self-organizing system. Over time, the weak ideas fade into the background, and the best ideas grow and are highlighted. A major US auto company came to us and asked to use our system to gain insight into improving their reputation among customers. So they invited 1,000 of their best, most valued customers to participate. In 4 weeks, we'd collected over 1,000 ideas. And it was far too many for anyone to read, sit down and sift through all these ideas. But when we looked at those with the highest scores, the largest blooms, we found many insights. For example, that they should concentrate on extending warranties, because warranties convey both confidence in quantity, in quality, and in stability. What also surprised us was that in a follow-up survey, almost all the participants said that they would be extremely likely to participate in the system again. So to recap, we've learned from our work in robots how to manage noisy, nonlinear data. And the result, the collaborative discovery process, achieves both scale and speed. Like Napoleon, we know that size matters. All leaders, and all of us, face very difficult, complex questions, especially in these turbulent times when there's an increasing uncertainty and anxiety about economics, about politics, about healthcare, and our environment. We have big data, and we have very big problems. It's time for us to work together to find big solutions. The website is now live. Right? David has launched about an hour ago. So we welcome new partners and new ideas. And we invite you all to join us in the collaborative discovery process. Thank you.
Yeah, you're spilling your water on the way in, you're spilling your water on the way out. Thank you. Next up,